Think about your smartphone. It's incredible, right? It can do almost anything. Now imagine building something that complex, millions of times over. That's where SMT machines come in. SMT stands for Surface Mount Technology. It's how we build the brains of our electronics, from phones and laptops to cars and spacecraft. These machines are like super fast, incredibly precise robotic assembly lines. They place tiny electronic components onto circuit boards, creating the intricate circuitry that makes all our gadgets work. Without SMT machines, we wouldn't have the amazing technology we rely on every day. SMT is a method for building electronic circuits. Instead of poking components through holes like old-school electronics, SMT mounts them directly onto the surface of a circuit board. Think of it like this. Instead of sewing buttons through fabric, you're gluing them on. SMT machines make this process incredibly fast and accurate. They handle, place, and solder tiny components with amazing precision. We're talking components smaller than a grain of rice. This technology is essential for miniaturization. As electronics get smaller and more complex, SMT allows us to pack more power into tighter spaces. An SMT machine is like a well-choreographed dance floor for electronic components, where precision and timing are everything. Several key parts work together seamlessly, each playing a crucial role in the assembly process. Feeders. These are like trays that hold reels of components ready to be placed. They ensure that the right parts are available at the right time. Imagine long strips of tape, each holding hundreds of tiny resistors or capacitors, all lined up and ready for action. Pick and place head. This is the brain of the operation, directing the placement of each component with incredible accuracy. It uses a vacuum or gripper to pick up components from the feeders, ensuring they are securely held during the transfer. Vision system. Cameras act as the eyes of the machine, ensuring accurate placement by constantly monitoring the process. They check the component's type, orientation, and position on the board, making real-time adjustments as needed. Placement system. This part moves with extreme accuracy, placing components onto the circuit board with pinpoint precision, ensuring each part is exactly where it needs to be. Soldering system. Once components are in place, they need to be soldered or permanently attached to ensure a solid electrical connection. This is often done with a wave soldering machine or a reflow oven, melting a special solder paste that bonds the components to the board, creating a durable and reliable connection. Section 4. The SMT Ballet, a step-by-step guide. Let's break down the SMT process into simple steps. Surface mount technology, or SMT, is a method used to produce electronic circuits where the components are mounted directly onto the surface of printed circuit boards, PCBs. First, preparation. The circuit board is coated with solder paste, which is a sticky mixture of tiny solder balls and flux. This paste is essential as it helps to hold the components in place and ensures a good electrical connection. Think of it like applying glue to a surface before sticking something on. The solder paste acts as a temporary adhesive until the soldering process is complete. Next, component placement. The pick-and-place head picks up components from the feeders and places them onto the paste-covered board. This step is highly automated and precise, ensuring each component is placed accurately. Then, soldering, the board goes through a reflow oven, where the solder paste melts and then solidifies, creating a permanent bond between the components and the board. The reflow oven heats the board to a specific temperature, allowing the solder to flow and form strong connections. Finally, inspection. After soldering, the board is inspected to ensure all components are correctly placed and soldered properly. This can be done manually or through automated optical inspection systems that check for any defects. And there you have it. A finished circuit board ready to be assembled into a smartphone, a computer, or any other electronic device. This intricate dance of machines and materials is what makes modern electronics possible. Section 5. Why SMT matters, efficiency and precision. So why is SMT so important? Here's the deal. First, miniaturization. SMT allows us to use smaller components and place them closer together, resulting in smaller and lighter electronics. Second, speed and efficiency. SMT machines can place thousands of components per hour, making the manufacturing process much faster than traditional methods. Third, accuracy and reliability. The precise placement and soldering of components result in higher quality and more reliable electronics. And finally, cost effectiveness. Although the initial investment in SMT equipment can be significant, the increased efficiency and reduced defect rates lead to long-term cost savings. Section 6. SMT versus through-hole technology, a new era. Before SMT, electronics were built using through-hole technology. This involved inserting component leads through holes drilled in the circuit board and then soldering them on the other side. While through-hole technology is still used for some applications, SMT offers several advantages. First, component density. SMT allows for much higher component density, meaning we can fit more components onto the same size board. Second, smaller components. SMT components are generally smaller than their through-hole counterparts, further contributing to miniaturization. And third, automated assembly. SMT is highly automated, making it faster and more efficient than manual through-hole assembly. Section 7. The future of electronics. Smaller, faster, smarter with SMT. SMT, or surface mount technology, has revolutionized electronics manufacturing and paved the way for the incredible gadgets we use today. By allowing components to be mounted directly onto the surface of printed circuit boards, SMT has enabled the production of smaller, more efficient, and more reliable electronic devices. As technology continues to advance at a rapid pace, SMT will continue to play a crucial role in the development and production of next-generation electronics. This technology is not just about making things smaller, it's about enhancing performance and functionality. First, wearable electronics. SMT enables the creation of smaller, lighter, and more powerful wearable devices. These devices can now offer more features and better performance while being more comfortable and convenient to wear. Second, the Internet of Things, or IoT. SMT is essential for building the tiny connected devices that make up the IoT. These devices can communicate with each other and with us, creating a network of smart, interconnected gadgets that make our lives easier and more efficient. Third, artificial intelligence, or AI. The powerful processors and memory chips required for AI rely heavily on SMT manufacturing. This technology allows for the creation of high-performance components that are essential for AI applications, from machine learning to data processing. The future of electronics is about pushing the boundaries of what's possible. With advancements in SMT, we can expect to see even more innovative and groundbreaking technologies emerge. And with SMT, we can continue to shrink devices, increase functionality, and create a world where technology seamlessly integrates into every aspect of our lives. From smart homes to advanced medical devices, the possibilities are endless.